Yeah, hi. So today's topic is exercise 3.6. So if I explain this exercise, this chapter will be completed. Okay. Now aside, I want to explain one more thing. What is it? Perpendicular bisector. Okay. What is perpendicular bisector? Okay. Now if I take a line segment called 6 centimeters. Okay. Now this is 6 centimeters line segment. Okay. From here it is. Okay, this is 6 centimeters line segment. What is exactly half of 6 centimeters? Okay, because it is 6 centimeters, you can easily say 3 is the half of 6 centimeters, right? Now this is the 6 centimeters and 3 is the midpoint. Without measuring, you need to find out the midpoint. You need to draw a line segment which intersects this midpoint at 90 degrees. Okay, now how can you do that? Take a compass. Okay, now this is compass, right? Now without measuring, now you can say this one is exactly half, right? This is exactly half. You need to take more than half. This is some A and it is B. Okay, from A I am taking now this is exactly middle, right? Approximately it is a midpoint, but we need an exact midpoint. So for that, what you have to do, take more than half measurement. Either you can take, even here also you can take. Okay, this is a midpoint. Okay, approximate midpoint is here, so I am taking more than half. Now this is half, more than half. Either you can take here or else here also you can take. Okay, whatever. So I am taking here. Now from your point A, draw an arc on top and bottom. Okay, now with the same measurement, by making P as a center, you draw an arc with the same radius. Okay, on top and bottom. Wherever these two arcs are intersecting, okay, name it as some P and Q. Join P and Q. Okay, join P and Q. This P and Q exactly intersects AB at its midpoint, that to 90 degrees. In a 90 degrees angle it is intersects. So this is called as perpendicular bisector. Perpendicular is nothing but 90 degrees, intersecting at 90 degrees. Okay, bisector is nothing but when it is intersecting in such a way that these two are equal. It is intersecting at its midpoint. Okay, let's check, okay, whether it is correct or not. Obviously. Okay, now see here, exactly at 3 it is intersecting, yes or not? So I didn't measure with a scale, but I just done with a compass. So take more than half, draw an arc top and bottom on both the points, both the end points. Wherever these two arcs are intersecting, join them with a ruler. Okay, now this will become a perpendicular bisector. Now this is perpendicular. Why? Because it is intersecting at 90 degrees. Okay, now this is 90 degrees, yes or not? No. So it is 90 degrees. And bisector, why we are calling? Because it is dividing AB at midpoint. So if you observe, this will be 3 centimeters and this will be 3 centimeters. That is why it is called as perpendicular bisector. Clear? Clear? Now when it comes to the question, exercise 3.6. So there are 3 questions. Let's take the first question, a question. Rhombus CART he has given with CR is equals to 6 centimeters, AT is equals to 4.8 centimeters. Rhombus rough diagram. Okay, so as we know, rhombus, all sides are equal, right? Okay, but diagonals are not equal, they bisect perpendicularly. Okay, perpendicular. Now what is this? CART. Now CR is equal to 6 centimeters. Okay, this is here is 6 centimeters and 8 is 4.8 centimeters. Don't think smaller, but we have written 6 centimeters here, 4.8 centimeters. It is a rough diagram. I didn't measure with a what we call a ruler. Rough diagram it is. So we can write whatever measurements he has given. I have written here 6 centimeters, 4.8. Now we need to take CR first as a first diagonal. Draw a line segment of 6 centimeters. Okay. This is a line segment measuring 6.6 centimeters. Now name it as a C and R. And you need to draw a perpendicular bisector to this. Now what is the exact 6 centimeters? Half of 6 centimeters? 3 centimeters. Don't draw by putting 6 centimeters like this. Okay. Perpendicular bisector is nothing but 90 degrees, making 90 degrees. So with the compass you need to do that. How to do? Okay, take more than half. Approximately half is this. I am taking more than half. Okay, more than half. Now draw an arc on top and bottom. Okay, the same by making C as a center. Don't change the radius. Okay, with the same measurement, draw another arc on the top and bottom. So you are going to get 2 points here. Join these 2 points. Now how much bigger? As much as maximum longer you need to draw. Now it is a line. Okay, now you have drawn a perpendicular bisector to this CR. Okay, so this perpendicular bisector meets exactly at midpoint. Okay, bisector, the word bisector in saying it is dividing equally, bisecting, by making 2 parts equally. Now if you measure exactly, it will be 3 centimeters. See here, 3 centimeters. Now name it as a O, the midpoint. Okay, from O, for example, if it is 6 centimeters, okay, and now it is O, from O to T, how much it will be? If the total AT is 4.8, from O to T, how much it will be? What is half of 4.8? 2.4. Yes. Now take 2.4 measurement here. This is 2.4. This is 5 and it is 4. Okay. Now take 2.4 measurement. Okay. By making O as a center, you need to draw an arc. Okay. Now by making O as a center, the same measurement, you need to draw another arc. Okay. If you measure these two from here to here, it is 4.8. Okay. Clear? Now, so half of you had drawn. Now you are going to get a point here. Okay. Now name it as a T and here A. Now join CART. CART. If you observe, now it is join these. These all sides are equal. Now if you want, you can check here. Okay, 0.0 from here, 4. Yeah, it's 3.9 somewhat. Okay, now here also it will be in the same 3.9 like that. Okay, now here also 3.9. So if all sides are equal, then only we can say it as a rhombus, right? Whatever you have drawn, in the same way you need to write steps. Now what is the first step? Draw a rough diagram of rhombus CART. Okay, now second, what you have done, draw a line segment CR is equals to 6 centimeters. Okay, here is 6 centimeters. Okay, next, third line, what you have done, draw see, I'm just writing here, draw a perpendicular bisector of CR. I'm not take more than a half, draw an arc on top and bottom. I am not going to describe all those things. Just draw a perpendicular bisector of CR. Okay, which intersects at O. Name it as a O point. Now from O point, by making O as a center, or else draw an arc on top and bottom of perpendicular bisector arc with 2.4 centimeters radius. See, from O point, draw an arc with a 2.4 centimeter radius on top and bottom of perpendicular bisector, which cuts at point T and A. Last point, join C, A, R, T. That's it. Okay. Have you understood? Now what I want to explain is, see, here we have taken 6 centimeters. You can take even 4.8 centimeters directly. 4.8 also you can take. You can take 80 also. AT also 4.8 centimeters. What we call line segment. Now from this you can draw perpendicular bisector. Okay. Name it as O. Now from O, the other diagonal is 6 centimeters, right? From here you need to take 3 centimeters arc. From here you need to take 3 centimeters arc. Like this also you can draw. Okay, you can take any diagonal as a base. Okay, clear? Now why I have selected 6 centimeters means, if you see the other two examples, 4.3 is there, 5 is there. So first you can take 4.3. Okay, some diagonal SA. Now from here you can draw perpendicular bisector. Okay, now from here O, you can now OP is 5 centimeters. So here you have to take 2.5 diagram, 2.5 centimeters arc. Here also 2.5 centimeters arc. Join them. Okay, now this will be the second one. Third also same easy. Okay, clear? You can solve 3.6. Thank you.